Hi guys, I'm happy to meet Steve today and his talk on security and secure development.
Hello.
Before Steve starts, I encourage you to ask all the questions in Telegram chat and join our discussions in Zoom after the talk. So Steve, welcome.
Thank you. Yes, it's fun. This is my first go at this conference. I've always tried to do it physically, but never worked it out. So it's nice to be able to do it at last, even if it's just virtual. Yeah, cool. So I have a bunch of stuff to talk about today. And as you probably gathered from the title, it's about creating safer software. It's for developers, so hopefully the audience is developers. It's not particularly taxing, but hopefully it's fairly informative and people will begin to get a little bit better understanding what they could do as a developer to create safer software. Yeah. So from a background point of view, just so you understand my credentials, I'm a developer. I spent 28 years at IBM doing JVMs and things like that. But I've always had a passion out talking to developers about what we could do to make things better. And for a few years, I ran a DevOps team at IBM, and I learned a lot about the sort of cyber attacks and security issues. And so when I got back to doing developer advocacy, which I'm doing now, I thought it's really, really important that we teach everybody just a little bit more about software safety and just what's actually happening out there and why they should pay attention. So that's mostly what the talk's going to be about.
Steve, I started to notice more and more talks on security on developer conferences. It's some kind of new stuff because several years ago you couldn't find a single security topic. Do you think is it a fashion or some kind of hype? Or is it really developers' attitude shifting towards taking more responsibility?
That's such a good question. Honestly, I don't know. I don't believe it's fashion. I believe it's finally developers beginning to understand that they have to do things. I wonder just how much is driven by their organizations understanding that they too have to deal with these issues, and that it's beginning to percolate down to developers having to pay attention. You know, for a long time, we always used to say there used to be security people, you know, and we always go, oh, the security people will deal with those things. But I think with things like DevOps and other movements, maybe it's just becoming more important for developers to learn this stuff. I hope that's the case.
Yeah. Let's see.
Yes, it is. It's funny. It's funny because when I was before I took over this DevOps team a few years ago, as a developer, I was completely naive about security. I had no understanding of why it was a problem and what I should do, how my behavior should change. But once I took over this DevOps team and I learned from the IT people just how bad things were if you let it get that way and what you should do as a developer, it was just an eye-opener. So, one of the reasons I'm doing these sorts of things is because I want to share sort of the things that I learned, and nowadays just how bad it's out there and what it is that developers have to do just a little bit to create safer software. That's the talk.
Yeah. So let's start.
Yeah, cool. So can you see my screen? Hopefully. I don't know if I know how do I I'm assuming that you can see my screen. So let's show. Okay, so we just talked about the title and we just talked about me. So I said I worked for IBM for 28 years doing JVMs and other stuff. And I moved to Red Hat and I did some work there. You may have seen me driving the Quarkus Community Roadshow. And then I got this opportunity really recently to come and work for Sonotype. And they're the company that run Maven Central and produce things like Nexus and others. And their one of their passions is security from a developer's point of view. And that's what I want to talk about. So it became a sort of like, oh, I'll come and work for you. And we'll go out and talk about improving security in all sorts of aspects. So This talk, it's a long talk. There's a lot of slides here, so you have to pay attention. Hopefully it's structured so you'll be able to follow along. If you want to ask questions, then put them in the chat, and we have a couple of points where we'll probably break and answer any questions. What I want you to take away from this talk is literally three things. One is, as you'll learn, that the situation in terms of cyber attacks and how your systems are being generally attacked are going up. So there's going to be a lot more of these sorts of attacks in the future, and we'll talk about those. And much as we may, as developers, think that it isn't our problem, security is your problem because it's everybody's problem. And as a developer, there are a few things, again, that's what we're going to talk about how you can think about changing the way that you behave, and some really simple things about how you create your code. Because at the end of the day, you can make a difference to this. It's as much as it's in your hands as everybody else, because security isn't about silos, about individuals doing their piece. It's about everybody working together. And at the back end of this talk, I'm going to talk to you about something that's happened quite recently. That's the first signs of more people working together, and how that's going to affect how we do things. So I've broken this talk into three principles. And you can just divide how you attack security in multiple ways. But ultimately, there are three things that you want to worry about. You obviously want to prevent the attacks. That's number one. What can you do to make it just harder for the bad guys to get at you? Then, if they do get in, how would you know? What could you do to your software to make it more obvious that things are not going the way that you'd expect? So detection. And the third one is, well, okay, so they got in, you've discovered it. What should you have done? Because you can't do it after you've been attacked, but what should you have done up front to make any attack less effective? What can you do to mitigate the way that these attacks roll out? So I'm going to start with the big one. I'm going to start with prevention. And the very first thing you have to think about is this. You have to take this seriously. You're going to see through all this just how seriously you have to take this. But quite often, I talk to developers about security, and there is this common meme that actually it's 15-year-old hackers in their bedroom having a go and having a fun, just attacking things because it's fun. Not intended to cause any damage, not intended to steal things, just basically it's fun. And yes, these people do exist, but it's not really like that at all. It's much, much more organized and much more dangerous. So when I say take security seriously, it's interesting because when you talk to developers, you go, so how safe is your data? What's in play? What process do you have to make your stuff safe? What tools do you use? What processes? What security aspects? And pretty much you talk to any developer, and of course the answer is you don't know. Because most developers don't think about this. And if you do think about it, you think about it in quite compartmentalized views. What's really scary is that the world runs on software. Everything that you do, every aspect of your life is driven by a piece of software. You've got mobile phones, that's got software in it. You've got headsets like I'm wearing, it's got Bluetooth, it's got software in it. Every aspect of our life, there's some piece of software run somewhere. And the world runs on that software. As a developer, whether you're a Java developer, a Node developer, or a C developer, your software is there to power the world. And the problem is that your software, like all software, is under attack. Now, when I started doing this sorts of talk, about 5 or 6 years ago, it was pretty bad. And I used to say some things. So let me just reprise what we used to talk about. So 5 years ago, when I started talking about cybercrime and cyber attacks, I'd say things like this. Organized cybercrime is the most profitable type of crime. And it is, and it was. You can see some of the numbers there. The really scary thing, and this was about 2015, 2016, that sort of period of time, that the amount of money that was being forecast, that was being collected by those people involved in cybercrime, was about $445 billion, which turned out to be slightly more than what was considered being the revenue, so to speak, for all the people involved in the illicit drug trade, which was about $435 billion. So just think about that for a minute. 5 or 6 years ago, we were saying that cybercrime was worth the same as the drugs trade. You think about all the movies you've seen about drug trade, about people burying money in the ground in containers, working out what it is by how much it weighs. You just think about all those aspects. Now think about this from another point of view. Think about which of those two types of crime would be most advantageous. Well, cybercrime pays a bit more, but actually it's also the one which has the least risk, because we can't catch cyber criminals because we have no laws. It's very, very hard to find out who broke into your system and stole your data. And even if you could, they're probably on the other side of the world. How would you prosecute them? So you can see it's a very, very valuable activity for people who are involved in it. And which one is growing the fastest? So again, this is me saying this 5 years ago. Which is the fastest? Well, of course, you can guess it's going to be cybercrime. Right? And we made predictions. There were some numbers being predicted then based on the evidence that we had that said by about 2019, that $445 billion would have grown to $2 trillion. And by the time they reached this year, 2021, it was going to be in the region of $6 trillion. It just boggles the mind. And when you put that as a chart, right, you start to see the scale. So here we are. The red line is the cybercrime line, and the green line is going to be the drug trade. So let's see what we said. So that's what we said the prediction was. The prediction was that the drug trade was going to stay pretty much the same because it's a physical thing. There's only so many people involved. There's only so much you can move. The police forces know how to deal with it. It's still a big number, but it's manageable. Cybercrime has no caps. There's nothing physical about it. It's just about opportunity and people involved. And there we go. That's where you can see what happens. This is our prediction way back in 2015, 2016 as to how bad it was going to get. And they're predicting by now we could be seeing it costing $6 trillion. So where are we actually today? I'm not going to tell you the numbers yet, but I'm going to tell you that what we have today is much worse, much, much worse than we expected. And the consequences of that are that as developers, our world is going to change, and it's just beginning to. So let's talk a bit more about some of the things that you could do. So why do you get attacked? Because it's actually profitable. It's not always about the money, though. So you saw those charts, and that chart talked about money. But the big change that's happened in the last year or two has been another realization that actually it isn't about the money anymore. The money is a big thing, but it's about something else. It's about this. So we had a lot of bad guys who were trying to hack our systems and steal our data to make money. And that still goes on. That's still a real big aspect of it. But what else is going on is an understanding that the next war, if there is ever a next war, is going to come squarely on top of our ability to control other people's systems. So cybercrime has become weaponized. Everybody's involved in figuring out how they can get into somebody else's system and do things to it. And we're now talking about actors who are state-funded, who have different objectives, not just to make money. And the reason that you would have seen a rise in some of these attacks is not necessarily because they were unexpectedly revealed. Some of these attacks are being shown up because how do you show that your weapon works? Well, you do something like a major ransomware attack across tens of thousands of systems, and people report it. So some of these attacks that you're seeing are just to demonstrate that the systems work. And you will have heard about certain systems being taken off downline, ransomware attacks. Many of these are indicators of people exercising basically weaponized cyber attacks. So think about what they're trying to do. This isn't about just stealing data. It's about getting into your systems, looking at whether you're pharmaceuticals, whether you're supermarkets, whether you're power stations, wherever you are, they want to get into your systems, right? Because what they're trying to do is manipulate or disable. Imagine the chaos that could take place if simple things happened. The traffic lights in your local city worked incorrectly, not just out, but they didn't work correctly. If your supermarkets couldn't place orders, it doesn't take much to imagine just the amount of chaos that can be caused if you can do this. So this is about being able to get into systems quietly and be ready to manipulate them. And as I said, but also demonstrating that they can do it, just because obviously you want to have proof that your systems actually can deliver. So this means we're not in the same world we were a few years ago. Now, the interesting thing is these bad guys are targeting open source. Now, open source is the biggest thing that we have. 90% of a modern application is made up of using open source code. We all use it. It's there, right? These guys are now trying to target that, and in all sorts of ways, which we'll talk about. But you've got to understand that these people are well-funded, they're relentless, they are as skilled and as educated as anybody else, and they're after you. And whereas before it may have been that they're after you because you left the doors open, this is also you're after you because you're part of one of those supply chains. We're all part of a supply chain. So the important thing is to think about that and understand that your systems could be at threat, not just because people are trying to make money, but because of your connections with other people. So understanding that takes you then into understanding how you get attacked. What is it they do to get into your systems? Right? Now, all the old stuff that's still out there are still botnets out there trying to still get into your systems. There are still bad guys who are working hard to steal your secrets. Right? There are people who still want to ransom your data. And there are still people trying to steal your CPU to do cryptocurrency mining and stuff like that. None of that goes away. They are all good ways into the systems, and so they get used. But now you can add other things, like open source project hijacks, which we'll talk again in a second. But getting into open source projects, getting fake packages put up onto common repository systems, adding malware into your build processes, into your tools. So it isn't just finding vulnerabilities in code that you're running that in your dependencies. It's also the whole way you construct your software is at risk. And it isn't anymore about doing it and running away. It's they want to get in there and do it in ways that you won't obviously spot. So whereas cybercrime criminals used to just wait for exploits, they would be looking for ways to exploit your code. They'd wait for CVEs to be reported and then exploit them. That still happens. But now they're making their own ones. This is really scary. So the number of times that you've put a dependency into your POM or something and you spell it wrong, if you're lucky, it will tell you that you've got the name wrong and it couldn't find that dependency on Maven Central. But if it was quite a commonly misspelt name, you might be unlucky because there might be one in Maven Central or NPM or wherever, which has a name that looks almost like yours, but with a spelling mistake. And now you've pulled down some malware and you didn't know. So this happens a lot. Now, they're also trying to go upstream and getting into the open source projects, because a lot of open source projects that we depend on don't have the capability, the people, to create the necessary processes and tools to prevent this happening. All it takes is somebody to turn up an open source project and offer to help. And if they've got malice in their intent, it's not impossible for you to imagine them actually being able to add deliberate weaknesses into the code. And the other two things on this slide: build tool attacks, targeting the compiler, targeting the operating system. Any piece of software that you run that isn't part of your code could be at risk. And these are being targeted because, as I said, it's all about control. Dependency confusion is another one that we're seeing in a few places. And this is just another example of developers typing in a dependency to use, but getting it wrong. So quite often people will put in latest as the thing they want to use, especially if you're in a development environment. Turns out certain repositories, well, what latest means may not be what you expect. So now what else can we talk about? Well, let's talk about another common thing that developers do is bypass security. Right? And you go, oh, no, I don't. Oh, but you do. Developers are very good at bypassing security. They turn it off. But actually, you can't do that anymore. As we're going to talk about in a minute, everything that you use should be considered harmful. You have to start thinking differently. You have to start thinking from a zero trust point of view. I don't trust this until I can prove it works. When I say developers don't bypass security, and developers, no, I don't do that. Right? Ever written code like this? If you're a Java developer, then you've probably battled with the Java Trust Manager, and you've probably ended up in a situation where you're trying to figure out how to get something to work so you can access some particular website with a self-signed certificate. And you Google for it, and somebody says, well, just do this. Create one of these and return true in the right place, and everything works. But you just turned off security. And the problem is this is everywhere. If you Google for this, or you GitHub search for these sorts of terms, like implements trust manager, what do you get? Well, I updated this number recently, 140,000 hits of those words. And when I say we make them into features, I do mean that. These are some words that are randomly pulled out of the searches. This is real code in GitHub. Some of this stuff might be in your dependencies that you're using. Your dependencies may have an all-trusting cert requester that you can use to just simply turn off security. We add these things in because we don't understand the consequences, and it's just easier. Now, I talked about dependencies and just how dangerous they can be if you don't choose them correctly, right? You have to now start thinking a lot more about how you choose the dependencies, not just for the functionality that they offer, but also for the other aspects. So we just go, I need to do this. There's a piece of code that does it. I'll include it in my dependencies. I'm up and running. Right? And we assume that the people who are giving it to us are trusted. We can't operate that anymore. You have to put more diligence into what you do. You have to look at the open source projects. You may have to make choices based on not only what it does, but how they think. What does that project do? Does it have a vulnerability reporting process? Does it use security tools? Does it have a very fast ability to provide you updates if it has vulnerabilities? Just what is their quality metrics? Now, you have to go dig into these things and start looking at them, but it's important to understand that you've got to start choosing your open source dependencies with more care and with more thought. And actually, what you've got to do, and when we get into the end of this presentation, it'll be a bit more obvious, but actually you can't do this by hand. We're going to start off by doing it hand, but we're going to automate this as much as we can, because we've got to be able to provide evidence to ourselves and to other people that these tools do what they say they did, and we've got to have pipelines of being able to deal with vulnerabilities as quickly as possible. Doing stuff by hand in this space is becoming untenable. So, what else do we do that's not too good? How about just not worrying too much about secrets? You know, we're not too good at that. We're very good at sharing passwords because it doesn't matter. We're not very good at removing them either. So here's a question. How easy is it to remove password data from your GitHub repo once you've committed it? Right? Now, if you're a Git person, you'll understand that the answer is it's not easy. But actually, again, if you go to GitHub and you ask for how many commits have the words remove password in, well, quite a few. They don't understand how Git works. They don't understand that changing something doesn't remove it, just hides it. And that's an attitude that lots of developers have because they don't really understand. And secrets get out and get stolen. It's a behavior thing. You have to think so much more about your behavior. So that's a lot of behavior stuff. What else can you do from a prevention point of view? Well, of course, you can start to think a bit more about how your application works. So I said you can't trust people. Well, now you've got to start thinking more about everything that you use and everything that you trust, right? Now, the most obvious one is data. Our applications do things, our code does things because data comes in. And quite often we just assume that whatever data comes in is trustworthy. If I get a request for something, then I'm going to do it. And I don't mean data like on a REST API, that's fine. But I'm talking about all these other places that data comes in. Your environmental variables, the command lines, right? Even data that you've given away. If you send data to a client and it comes back, are you sure it's the same data? Can you trust it? You must have a mentality that says, I can't trust the data the data that's coming in. Right? I almost can never trust the system's getting data from. Right? And you have to validate this. And it's hard for sure, but you have to start from that point of view of, is this what I expected? How can it be subverted? What can I do to reduce that happening? So let's give you a really simple example of how you have to think about these things differently. So a piece of code. I said there was some code in this talk. So here's a Java code. It's a piece of code that's going to use to drive an executable, which in this case is called Docker. And as you can see, I've got some fields, a couple of instance fields. I've got a couple of constructors. And what the constructor fills in the field with the name of the default location for Docker, the Docker executable. And it says, where should I write the output? Okay. And it's got a method, which we'll explore in a minute, which is we're going to use to drive the Docker CLI to give me back a list of active containers. Right. And in the black box is some example of how you drive this. You create an instance of something, you call a method, you get some responses. You know, that's fine. Nothing wrong with that. What validation should you do? Well, the very first thing, obvious thing is, well, in this instance, what would happen if that the location of the binary was incorrect? Okay, I've got an instance where I can create one of these and pass in any executable. I don't do any validation here. First thing is validate your input. So what would I do? So I'd prove that it was an executable, and I'd call it and see if it's got a version number. I'd do some effort to see whether what I've been given is valid. But it's more subtle than that. This particular class is serializable. So in fact, the object that I create is open to serialization attacks. And that means that any fields that I create, any instance fields, could be subverted. Just because I created this class through the constructor and I ran some validation at construction time, it doesn't mean that when I get to execute those methods, that those fields are what I expected, because it could have been serialized. This code that I've written might not be being driven through the code that I expected. It's a vulnerability, right? So validating during the constructor is good, but in some ways might be obsolete. What you've got to do is think about when your data get used and what you're going to do to validate it at that point. So as I said, all those fields are constructed. Now look, I've expanded out this method called active containers. So, it's pseudo Java, but you can imagine what happens. I've got another piece of code that's going to run the Docker. So it takes the default executable location, which is user local bin Docker, and adds on PS. That's all I have to do, Docker PS. And I've got a log file, which is where I want the output to go. Right? I have no idea whether what that's going to do and whether it's trustworthy. Okay? And I don't have any idea where it's going to write the output, because I'm not validating either of them at the point where I'm going to use the data. So if I was to take this instance and play with it using serialization, I could force the Docker path to be something else. I could get it to call cat, for instance. Here, look, I can get it to call cat using etc. password. Okay, the PS bit on the end will just get ignored. And where do I want to put the output? Well, I'm going to write the output to some HTML file on my web server. So this piece of code that could be exploited through some serialization to have those values and being driven by something else could leak whatever data I wanted. You have to understand that you have to validate the data at the right places and that it's going to do what you want. And you have to understand that just because you have a happy path through your code, which works for you, that doesn't mean it's going to be how the bad guys are going to use it. So related to this is a thing called API abuse. And this is the idea that just because you created some nice APIs, that people are going to use them the way that you expected. One of the classics is the concept of having something like a credit card number validation service. And quite often you see websites that if you're buying something, they'll put the number in and it'll do a validation. If that API gets discovered and it's a separate microservice, for instance, it's classically open for exploitation for validating, stolen credit card numbers. It's really easy to use. Not what it was intended, but what it got used for. And when I say your private APIs are vulnerable, actually, it's quite feasible with the right sort of investigation to find maybe some of your test endpoints and do some bad things to those. You can expect that any API you put available out there is going to get explored and it's going to get used against you. So look, they're going to take the APIs that you publish or the APIs that they discover, and they're going to try all sorts of different things to see what they can get. They'll try all the different verbs. They'll play with the APIs. If you have a REST API, you've already given them some clues as to how you're going to structure it. Right? And they'll play with the cookies. What cookies do you want? What's the data? What happens if I change these things? Now, the scary thing is that this whole process of exploring your API has a name, and it's called fuzzing. And it's a well-established test process, and it's a well-established security penetration process. Fuzzing is the ability to take your APIs and play with them and try different things. What happens if I pass in negative numbers? What happens if I pass in the biggest number of the system? What's going to happen? This is already out there. People are already providing these tools for you to use. Fuzzing is just everything you can think of. Somebody has already thought about it in terms of having a go at your system, passing in the big list of naughty words, which isn't what you think it is, but it's actually data that can be used to crash your systems or find ways into other places. Right? There are tools out there to do this. There are all sorts of things. This is a bad space because it's fully automated. Once you get an API, you can apply the tools. These things are automatically discovered. Your API is automatically discovered, and they can be attacked with bots without any effort from anybody. It's like, imagine you're living at home and there is this burglar, and he's going to be trying every one of your doors out of every building across the planet 24/7. This is what's out there now. That's how automated it is. It's easy for these people just to fire these things up. So how long do you think you have from publishing your REST API to these guys turning up? Well, if you put it on a public cloud, you probably have a couple of seconds. You might be lucky and have a bit longer, but quite often it's literally that long. So you have got to change the way that you write code. Now, you have got to think about coding defensively. We always talk about this. Lots of people talk about this. So I've got this here as one slide because there are a bunch of stuff that you can do. And you can go read about the details of how to code defensively. Lots and lots more examples. But ultimately, it comes down to a few things. You've got to assume that you're being attacked and that the requests that are coming back from the clients and other servers aren't necessarily going to be correct and valid or trusted. So you have to build into your system the idea that that's the case. You have to understand that you're getting a request in and that it's not an order. Don't treat it as an order. When requests come in, validate it. See what it's asking you to do. What state changes it's trying to get you into. Is that valid? Is that reasonable? Don't assume just because the data says something that you should agree. Okay. Now, some other things you can do, we'll touch on these occasionally. Review all the error messages. We'll come up with that one a bit later on. But basically, don't give too much information away because even error messages can help the bad guys into your systems. And headers and cookies, that's a good one. It's quite interesting how you can find that one of the signs of being attacked is you're getting back more cookies and headers than you were expecting because they're probing your systems. Do you check for that? Now's the time to start thinking about those sorts of aspects. And your code quality. Ooh, code quality. What can I say? If your code is complicated and difficult to understand, then it's going to have holes in it. And those holes just naturally get found because there's so much tooling out there to help find it. Okay, so prevention, end of part 1. There's lots of things that you should take away. You should be taking away an understanding that cybercrime is not going away and that it is getting much worse. You've got to put effort into understanding how you get attacked. You've got to understand that you need to think a lot more about the code that you use and that you consume. And literally, you've got to start taking this much more seriously. So I'll pause there for a second. Do we have any questions?
No, we have no questions yet.
Good, good. Right. Luckily, that's the big section, and then we've got a couple more. So believe me, we should be okay. Right. Let's carry on. Detection. So what do you do? A few little bits and pieces that you can do. So the first thing is you've got to understand what the bad guys are trying to get from you. It's not just about stealing your data and CPU. The interesting thing is that we all have stuff of value. And as we're discovering, sometimes it's not just about stealing your data, it's about adding to your data. There are more and more examples, especially of, or as you can imagine, around sort of cyber warfare positioning, where it would be quite advantageous if you could hack a credit card company and not just steal the credit cards, but add some more. And that's already happened. So there are lots of you have to understand, and the best thing to do is take a good look at what people are doing and how they're attacking you, but understand it's no longer just about stealing your data or ransom you. It's much more subtle. And your value may have nothing to do with the data that you have, but it may just be to do with the relationship that you have with another company. Right? Now, you have to check for abnormal behavior. Now, I could put all sorts of pictures up for this and for the next one, but I haven't. It's just like, let's just talk about a couple of things. So deep and wide. One of the things that developers do is they think the bad guys are like them. And so we write code and we write an API and we run some unit tests and we go, yeah, that's cool. That works what it wants. And then we give it to somebody else to test it in more detail. The bad guys aren't thinking that way. The bad guys are going to look at your API and go, how do I attack it? What security have you got? How do I work around it? So they're going to be coming at you by driving your API and exploring all the aspects, the deep thing, using things like fuzzing, to understand if they can find edges where you're broken. But they'll also be coordinating those attacks across botnets. You could literally have tens of thousands of people penetrating your system. Right? Now, you might spot the fact that one REST endpoint is being driven badly because that may be how you think. But if you realize that actually what's happening, these guys are attacking your REST API from 10,000 different IP points, and they're all going to do something slightly different, you may not spot that. So here's the challenge for you. You have to think about what abnormal behavior looks like for your application, both in an individual REST endpoint and as a system as a whole. And of course, the corollary to that is that it's no good just detecting it, you've got to report it. Now, there are many tools out there that can spot bad behavior if you let them. Lots of tools out there that if you write the right things in the log, then hopefully they can spot those patterns. So it's up to you to work out what unexpected and abnormal behavior is, but once you start reporting it, you can hand it off to other tools. It's not hard. You've got to start thinking about providing evidence to yourself that your system is under attack. Now, we all use REST API because it's a nice common way of doing it, but you don't have to do it to be helpful, because you can be too helpful. So some things that you can do. Okay? Think about what you expect the client to do with the data that you've given it. If they make this call, then I would expect them later on to do a call like this. Now, it may not be completely deterministic, but start thinking about, well, if I get this call, I don't expect to get this call afterwards. And if you do, then you start raising the flag that maybe something's not right. Okay? And if you do put information in the log, make it useful. Quite often you get an error occurred type log, or something bad happened. That's not good enough. You want to put more details in. But also, if you put too much in, then actually you can help the bad guys, because your logs are not necessarily as private as you make imagine, because they can be leaked inadvertently or found. So you have to think about that as well. It's all very difficult. Right. So how you deal with errors, some more code. So here's a piece of code that loads properties. Now you have a properties file, maybe backed by system.get_properties, right? And then you go looking for another config file, and you go, if this file exists, then I'll load it. And if I get an IO exception, I'm going to assume that really sort of maybe something happened. Maybe my exist was the wrong type. I should check for it being a file, not directory or whatever. And I just go, well, if I get an IO exception, then fine, whatever, move on. But actually, there are whole reasons why getting an IO exception of the type that you weren't expecting could be a sign that you're being attacked. So be very specific. Track the errors that you expect, and the ones that you don't get, report it. So in this case, you go, I would expect to get a file not found exception. Okay, I don't really expect to get it, but that's the one that would mean to me that I'm supposed to behave in a certain way. If I don't get that, then I'll do something else. Maybe I'm going to fail. I'm thinking through the consequences of the errors that I get and not just assuming I can ignore them. Right? So detection, this middle section, is about you thinking about how your application should behave and building in the heuristics and the reporting to say it's not behaving the way I expected. You don't have to fail. You just have to report that what you're expecting to happen isn't. And you have to think about the fact that people out there are very sophisticated. It's not one REST endpoint. It's not one IP address. It could happen in very detailed ways or very subtly. How would you know that your application is not working the way that you expected, or that your end user is behaving differently? Right. So if it's unexpected, report it. At the very least, you may find that the behavior application is quite valid. It's just that your users aren't doing what you expected. So that's a bonus. But at the very least, being able to understand that this is happening is really important in the way that you create your applications. Cool. See, I think that was quick. Do we have any more questions? Nobody come up yet? No?
Yes, we have a question.
Okay. Oh, cool.
The question is, a well-known security principle is to avoid extra data in logs in order not to reveal some sensitive information. But developers often need to log extra data to be able to reproduce issues or debug some problems. So how to detect situations when you need to log extra data and what data is sensitive and what is not?
Yeah, so you don't have to log sensitive data to say that your behavior is not what you expected. Let's an example. Let's suppose that you've got an application and you would expect to get a call of one type and then followed by some calls of a different type. So what you do is you build that into heuristics, and if you don't get that, you go, this IP address is behaving badly. Here are some facts about what it's doing. That's all you have to log. You don't have to say, you don't have to put passwords or things like that. You just need to show that it's happening. Now, for me, that seems to be the straightforward piece. You need to know it's happening. You don't have to put passwords. You just need to have built in some logic, and you just say in your logs, this bad thing's happening. Right? That's it. And if you go, well, this IP address is behaving like this, and then you get another log entry that says that another IP address is behaving like that, now you begin to see that things aren't going the way that you expected. But if you never put the first bit out saying, I'm not getting what I expected, then you're never going to know. Okay. Cool.
But you might need to log some identifiers like object IDs. Whatever.
Yes, uniqueness for sure. And whether or not how detailed you go is going to come down to how much you need to know to do remediation. But you don't necessarily have to just go user ID XYZ. And to be honest, that comes later. Once you know that you're being attacked like this, then you then start to think about how you're going to deal with it and how you're going to mitigate it. And that gets more complicated. Yeah. So I'm not saying there's any easy answers. You just have to understand that there's significant value in writing things to logs. And if you have to put a bit of sensitive information out there, then that may be the right call. What's better, to know that you're under attack and leak a bit of sensitive data, or lose it all? Yeah.
I think it's an interesting discussion, but let's move forward.
Okay. The last bit. Right, where do we get to? Okay, so mitigation. I'm going to mention a couple of bits, and then I'm going to talk about something else. Mitigation. So this isn't mitigation after the fact. This is mitigation about how you design software a little bit. Right? And there's one really easy thing. Compartmentalize your data in your application. Right? And We already do a lot of that with microservices because that's quite useful to do that. But we don't necessarily do that in the right way. So the first thing is, we talked about fuzzing. So mitigation says make it harder for things like fuzzing to take place. So REST is fine. REST is there to help us understand how to use the API, but REST is easily understandable by bad guys. And if you follow it slavishly, like you put /API on something, then guess what? You can be found. So don't do that. Think about just calling your endpoint something slightly different. You could put API on for it for sure, but put a different keyword, not V1, because believe me, every version of V1 is out there and programmed into the bot because that's what they're going to do. Pick something else. Simple things like that make a difference. Right? And look about, do you have to use port 80? Are you doing internal things? Could you do something different? Do you want to add some special validation headers that the fuzzing tools will have to spot that they need to do that too? Right? Think differently about how you interact with the API, right? And make it just harder for people to call it in an unspecified way. And then think about the data you give back. We said about minimum data in the logs. Well, minimum data on any request, right? So 2 really good examples, right? If you're going to provide somebody, say, with an address to post something to, don't ask your application to go and ask for a user and get the details from there. Have an API that specifically returns just the data they use, right? Because obviously you don't want to leak anything else. That's just a no-brainer, right? Compartmentalize your data by the use cases and make it the client's job to get the bits that they need. Right. Right. And then don't just return raw data. I mean, if you've got dates, make the application work. Don't give out a date field which has got dates in, because that's easy to understand, right? Right? Do it something like this. Make the API request some date number, right? And then give the information out as offsets or something like that. Make it harder for the bots to figure out what's going on. And I said about logs, don't go too far, because if you put too much information in your logs, or even, of course, in the error reports that we occasionally send back to the client, that really helps them sometimes, because it lets them know that they're tracking your API calls and they're getting close. You'll get information about how warm they are, right? And all sorts of other bits and pieces, including version numbers of applications, of frameworks and services you're using. And why is that a bad thing? Because if you give out the version number of what you're running, they can go look up vulnerabilities and try that version's gone. Other things. Don't build applications using the idea that authentication is this sort of concentric circle idea, where you have no authentication all the way up to super users. I'm root or I'm not root. Don't do that. Right? Your authorization should be based on the use cases that you're driving, so that if the bad guys manage to get into one, they can't do the other. Your bad guys get root access, then everything's off. If they get access to the calendar API, that doesn't mean they can figure out the address of the users. So mitigation comes from compartmentalizing not only the code and the data, but also your access control. A couple of other things that you should do. Take away all of the tools and scripts and dependencies that you have that you do not use. Every single one of those is a threat. Every single one of those is a way in. And if you're not using it, get rid of it. If you're using Docker containers, then strip them down and take everything else. If you're using OSs, then again, figure out what you can take away. Just get rid of everything, because every single one of those is going to be a threat vector. and don't have a developer mode. So often we have developer modes, and one of the really classic ways of getting into systems is by forcing them into developer mode. Because developer mode usually means no security, no checks. Have a really good think about, if you've got a dev mode, about whether you really need it. And write code with the idea that you don't need to do it. Get your authentication processes sorted out, your authentication thinking, so that you can do what you need to do without having to turn it all off. Right. So this little one is all I've got, because I've got something I want to talk about in a minute. But this is something else that we are poor at. We never look at the holistic whole of the process of creating our software. So what we're very good at doing is paying lip service to security on build processes, on Jenkins, on the GitHub actions that we use. We just use them, and we do nothing to think about the consequences of allowing unfettered access to the build processes. Think about what would happen if the compiler that you're using was corrupted. Think about what would happen if the Jenkins server that you're using added extra stuff into the releases that you're publishing to GitHub. And these things have and will happen unless you think and secure the pipeline that you use to create your software. It's just as much a vector for getting bad things to happen as your code. Right. So that's the last bit. As I said, I have a little tiny bit more I want to cover. But mitigation, there's all sorts of things that you can do to mitigate. You have to think about how your data is being, how your systems are constructed. But obviously, compartmentalization. Think of it from a submarine point of view. How do I stop people coming into one service getting to the other? Right? How do I reduce the information that I'm giving the bad guys so that they can't exploit me? And how do I get my authentication set up so that them breaking one doesn't give them the keys to everything else? Okay, see, I told you that was even quicker. Right. Well, look, I'm going to do the last bit, and then we'll take questions. This last bit will take a couple of minutes, because it's interesting to see how the world moves on. I'd said at the beginning about how cybercrime has entered this new reality, how we have state actors who are thinking more from a cyber warfare point of view. Well, things are happening because of that. So this year, the US created, or Joe Biden put together, an executive order which is about improving the nation's cybersecurity. And this is the very first step. We've actually got something happening at a high enough level that's going to drive change. And the executive order is saying, hey, we need to do something about it. Starting to think about how we should work together. And because applying laws in the right ways works, they're also going, we're going to start looking at the requirements on you as a software vendor, about what you provide, what information you provide to the US government. Right? And this is going to change how we do things, because they're asking all sorts of stuff. Keywords are turning up, evidence. So they want to see that you have automatic supply chains. They want to see that you have evidence of your software security. Right? They want to see that you can prove that all the software in your supply chain, your dependencies, the tools you use, the operating systems you build on, also have the necessary integrity and proof as well. You can read the others, but you can see this is a major change. There's nothing on here that we haven't considered doing or that people are already doing, but now it's becoming real. And the key thing that we're putting this all around is this thing called an SBOM, which is a software bill of materials. The executive order outlines two of these, and you can pick one, but we'll end up using both. But basically, these are literally just specification documents to describe the software that you're using with the necessary integrity, with SSH 1024s and things like that. But ideally, it's a bill of materials. It tells the person using your software what's in it and where it came from and how it was built and how those things were constructed. So it'll have if I give you a piece of software, my S1 will have a list of all of the dependencies that I used and the tools that I used and the operating systems that I used and references to their bill of materials. So you as an end user can track that thing back. But that means, on the positive side, now we are starting to look at having a proper chain of evidence back to the source code somewhere for all of the things we use. But it also means, on the negative side, that we'll know more about the vulnerabilities in the systems. So you may not even think about the C compiler being used to produce the JVM that you're using to run your Java on. But if a vulnerability turned up in that C compiler that affected the JVM, now we have that chain so that you would know that's going to happen. And suddenly, you have much more information about the vulnerabilities in the system that you're using all the way through. And that means you're going to get even more pressure to apply fixes, which means much more focus on more automation and having those sort of tools. What can I say? This is long overdue. What we've got is the beginnings of change. It isn't anywhere near enough, but it's the beginnings. And it's going to happen quickly. And it doesn't matter where you are in the software world. If you're producing open source, you'll be part of this. If you're producing commercial software, you're going to be part of it. Because you can imagine that wherever part of the software chain is, you're going to end up being used by somebody, and they're going to start coming knocking at your door saying, you need to do this for us. Right? So, what can I say? All of this stuff, cybercrimes has just gone through the roof for a whole new set of reasons. We're still targeting open source. Open source is still the primary vector for a whole bunch of reasons. But the way that we're dealing with this is beginning to look very much more at having this automated, evidence-driven system. And because of automation, because they need to take human beings out of the circle, it's going to be everything as code. That's where we're going. And the next couple of consequences are those pipelines you used, the Jenkins servers that use stuff that you're using, they're going to slowly evaporate to be replaced with more and more off-the-shelf ones, whether they're commercial or open source. But bring your own is going to become less and less tenable because you've got to start providing this evidence so you can see where that we're going. And because open source communities are going to struggle to deal with a lot of the issues that they're being asked to deal with, you can expect to see more people doing that for them. And you can expect that we'll start taking more of our source code, not directly from these projects, but from other people in the middle, trusted vendors who are giving us the things that we need and working with those open source projects. But it's still all software, right? And it's still up to you, because as a developer, you're in the middle of all this. You have choices to make wherever you are, right? And as I said at the beginning, you've got three things to take away, right? The world is just, from a security point of view, from a cyber attack point of view, it's much worse than it used to be. It's getting worse, right? As a developer, it's your problem. You're part of you do software. Software is part of the problem. You have to change the way that you think about creating software. But you can do this. It's not rocket science. It just takes a bit of attention and a bit of thinking. Right, and I will stop there. Look, 1 minute. Sorry, I didn't really mean to take 50 minutes or 60 minutes, but there we go. Do we have any questions?
I'm afraid we have no time for questions here, so let's move to Zoom and discuss everything there. I just want to take a moment to thank you for this interesting talk, and invite all the listeners, all the guys to Zoom to continue our discussions. I personally have a couple of questions to ask.
Okay, cool. Let's move to Zoom. Thank you so much for doing all this. And I apologize for not giving you time to answer questions here, but we'll go do it on Zoom. Cool. Right, let's try that. See you in Zoom.